What is the use of instance method? What is the use of instance method? Not answering. To perform specific operation, right? On the object. What is the use of class level method? To perform common operation on the objects of the same class. What is the use of static method? To perform the universal operation or utility operation. That is what we discussed it. So don't remember only method purpose. You remember types of methods. What is the use of data members? To store the data. Instance data member stores what data? Specific data. Class level data member stores what data? Common data for all the objects of same class. Common data for all the objects of same class. So of saying of eating, that is not correct. You have to say everything to the point. Now, today we are entering into the next concept called what? Destructor I am going to discuss. With that, concept of class will be over. Okay, now? Shall we start up? Right. So let us go to the destructor concept we are discussing. And one more thing, index, if I open it, if I open the index of OOPS, I'm not writing the index again here. We are talking about here constructors as done in the last class. We are talking about what? Destructors in OOPS we are going to talk. This is the most important. Actually, that is not necessary to be known to the programmer, but in interview point of view, that is very important. So let's start with what exactly destructor is. So I'm going to write it. Destructor in OOPS, destructors in OOPS, okay, and relation with the garbage collector, Come in, ma. So coming to the point of it, index I'm going to talk. So there I'm going to talk importance, syntax, internal flow of relation between GC module and programming example. This is what the index is. So I'm going to teach a lot of examples. Actually, as far as this part is concerned, no need to know about this entire thing because everything is inbuilt internally. But we need to know programmatically what is happening. Whatever the class I'm discussing 1 hour 40 minutes, it's time waste. But you need to know about what is happening behind this destructor. We don't use in real world directly in the coding, but internally what is happening, we must understand it. So already we know what is the garbage collector, right? What is the garbage collector? Is one program, is a Python program, which is running behind of a very regular Python program, which collects unused memory space. So how exactly works, I'm going to discuss in the class. Carefully listen. And interview point of view, most important. In programming point of view, we don't use at all. Why we don't use it? We are going to discuss one by one. Carefully follow, guys. Now I'm going to start. Program for demonstrating destructor. How destructor will work? All those things we are going to discuss. So coming to the point back. So I'm writing an example. Class employee emp def underscore init underscore of self comma envo comma ename. What constructor it is? Parameterized constructor. Self dot envo is equal to envo. Self dot ename is equal to ename. This is my constructor which is available here. Coming to main program, here I am writing, coming to main program, here I am going to start print of program execution started, okay, program execution started. And now I am creating an object of it. E is equal to what? EMP of. Now I am writing next term. This is nothing but I am passing the data. What is the data I am passing? 10 comma what I am passing? Row sum I am passing here. Row sum. What is this is called? object creation. Object creation calls what? Object creation calls constructor. Object creation call constructor. Already you know this. Now, once an object is created, this is coming here. I will print the data also. What is the data I'm printing? \t, something like this. EMP, employee number, dot format of self dot envo, print of what? \t, emp name is equal to dot format of what? Self dot ename. This is what we used to print it. All. Now I'm going to take up students. Here I'm writing program execution. E1 is equal to, I'll say E2 is equal to emp of some 20 here, some 20 I'm writing, and some name I am writing here, Ashwin. So I'm writing here, I written like this. So object creation calls the constructor. Which constructor is calling? Parameterizer constructor is calling. And program execution ended. See very carefully. It's done. You execute. Here no destructor is there, nothing is there. Do you have any destructor concept here? No. So what is this program? I'm giving a file name as I'm writing non-destructor example1.py. There is no destructor concept at all, but I'm just writing the normal code like. So like a normal Python code, how you write in the OOPS with the constructors. So I'm going to take up students, save this code, go to that. Today I'm creating one folder, destructors. There I'm going to save my program called non-destructor example1.py. So there is no concept of destructor in this case. So I'm going to take up, coming to the point of it, D:. So I'm going to take up Python 7 AM. OOPS here. So destructor here. Now I'm going to run my code. py, you say py. I am writing something like this. What is happening? Like normally this data is coming. So in this case, what is happening? First object created, second object also created, execution started, execution ended. I'll create one more object. Just one separation of the line I will give you, students. One separation of the line I will give. So here I am writing like this, having one more object I'll create. E3 is equal to employee of 30, something like Prashant. I'm writing like this. Object creation calls what? Same constructor will be called. Then execute it. Three objects are created, and then like this it is happening. So program execution starting time, how many objects are there in my program? No objects are present. Before joining engineering, how many books you have? No books are available. No. So when the program execution started, there is no objects available. When the program is in progress, obj1 is created. Next, obj2 is created. obj2 is created. obj3 created. obj3 created. obj3 created. 1 created, 2 created, 3 created. When the program execution ended, the moment when this line is done, here GC is ready. Garbage collector is ready to collect memory space of obj2, obj1, and all these memory spaces will be destroyed. Right or not? But we don't know that. That we don't know means we are not necessary to write the special coding for what? Destroying the memory space. That's why Python people has given what? Python software is saying what? Java software is saying what? Whatever the objects you have created in your program, at the end of the program execution, garbage collector will eliminate the memory space of what? obj1, obj2, obj3, removes and added to the main memory of your computer. It is object one memory space brought from where? Main memory. Main memory, it is brought a memory space. It got a borrow of the memory space for my application. Second object also got the memory space from main memory. Got the memory space from main memory from OBJ3. After the program execution is over, whatever the memory space you brought it, you need to give it back to whom? Main memory only. So whatever the memory space you got it, that you are granting this memory space for this object. At the end of the program, garbage collector is destroying the memory space of OBJ1, OBJ2 because they completed the execution, right? And that memory space need to give back to whom? Main memory, that is the operating system memory, you brought it. You are giving the memory space back. Are you getting my point? So the point to remember here is garbage collector is calling at the end of the program automatically. And it is destroying the memory space, removing the memory space of these objects. Who is actually removing the memory space? Destructor is removing. Who is removing the memory space? Destructor. Destructor is internally called by whom? Garbage collector. So garbage collector is calling what? Destructor, which will remove the memory space of our objects. And that memory space will be given to the operating system once again. Are you able to understand? So what is the role of destructor in Python? It removes objects memory space. But is it calling automatically? No. Who is calling? Garbage collector. When the garbage collector is actually calling at the end of the program, what are all the objects are created in your program? At the end of the program, cleaning up process will be taking place. Cleaning up process, eliminating the resources. Whatever the resources you got it, those resources will be given back. By calling at the end what? Garbage collector is internally calling what? Destructor. The destructor will eliminate the memory space and added that memory space to the main memory of the computer. These are gunshot questions in interviews. So many things I'll show you. First of all, did you understand my point? What is the point you got it here? At the end of the program, garbage collector calls destructor to eliminate the memory space of the objects which are used in my program. PVM calls the constructor to initialize the object. Garbage collector calls the destructor to eliminate the memory space of the objects. In MCQs, they will ask you, which of the following method will be called by the PVM during object creation? Option A, destructor. Option B, instance method. Option C, static method. Option D, constructor. Constructor. Which of the following method will be called at the end of the program execution by the garbage collector? Constructor, destructor, method, and then what? Data members. Destructor, destructor. So what is the role of destructor? Who is eliminating actual memory space in our program? Destructor. Who is calling destructor? When it is calling at the end of the program. That is the main theme of the destructor. What is the relation between garbage collector and a destructor? Garbage collector is running in the behind of the regular Python program. Every end of the Python program, garbage collector automatically calls destructor to eliminate the memory space of the objects which are used in our present program. Understand? Now I am going to enter into the final. Here no destructor is there, nothing is required. Now I am writing the destructor. Shall we? Okay. So going to the next concept here. Now I am going to take up one more kind of example. That means garbage collector already contains what? Destructor. You need not to write what program? Destructor need not to write. Why? Already garbage collector contains what? Destructor. Is it necessary to be written by you? No. Even if we write, it is not at all considered by you. It already have its own destructor. So I'm going to paste it. Now I'm going to say destructor example 1.py program for demonstrating destructor. Now I'm writing. See the constructor name. Constructor name. So Tushara, listen. Okay. Don't excite. Listen the class. I will tell you one by one. At the end of the class, I will tell you what is you have. You have three objects. So you listen it, because our destructor I did not start at all. Only this definition I said. Listen it. Why are you exciting so much? So DEF underscore underscore init underscore underscore of this one. What is this is called? What is this is called? Constructor. Madhubabula, come on, speak out. What is this is called? Huh? Only good morning saying and sitting like a very cool people. What is this? Huh? Hey, Radha, what is this is called? Parameterizer constructor. Spell out. Class I will tell you outside. Go outside and attend online. What is this constructor? See, online people, how they are responding? Sitting in front of me and doing meditation. What is this is called? Which constructor? What are this called? Object creation calls what? Constructor. Now I am going to take up. One important thing I am going to take up here. I am writing destructor. So every garbage collector internally contain what? Its own destructor. Even if I write my own destructor, there is no use. Only for the people to understand that internally calling what? Destructor. DEF underscore underscore del underscore underscore del of what? Self. Of self. Now I am writing. GC calls underscore underscore del underscore underscore del. Right? Now I am writing for removing memory space. For removing memory space of what? Objects. Of objects. Now, that is the sentence I am writing. What is this meaning? What is this concept is called here? Destructor. Destructor function it is. Destructor method it is. What is this is called? A constructor this is called. What is this is called? Constructor. Who will call constructor? Who will call constructor? Who will call constructor? PVM. Who will call destructor? Garbage collector. When the garbage collector will call the destructor? At the end of the program. Now observe it. Here I am going to write it. Program execution started. E1 object created. E2 object created. E3 object created. Program execution ended. Now I am going to call time dot. Of course, I don't write it. First listen now. Destructor example 1.py. Destructor example 1.py. Done. Now see how the flow will be. So how the flow will be? PVM come to this place. E1 go to the constructor, execute it, coming back. E2 go to the place, execute it, coming back. E3 going back, execute it. Program execution ended. GC will come into picture. Will call what? Destructor. First it will see, is there any destructor in the class called what? EMP. Which objects are removing here? E1, E2, E3 are removing. It will verify. Is any programmer written destructor in the class called EMP? Yes, you have written it. Today you have written it or not? And it will go to, your garbage collector will go to this class and calls this. How many objects are there with you? 3 objects are there. 3 times objects are going to be destroyed because they have unique ID is there. Whichever is having the ID uniquely, that many number of times your constructor destructor will be called. So GC is calling the destructor how many times? 3 times. How many times? 3 times. Let us execute this code. Now I am going to say, execute this now. Carefully follow, students. Non-destructor example removed. Now I am writing this. Carefully see. Program execution ended. What is happening? You see. Program execution ended. What is calling? GC calls del for removing object memory space. How many times called? 3 times. For you to understand, time dot sleep of something like 5 seconds I will give. 5 seconds. Import what? Time. Import time. Just only for making to understand. It is waiting. Program execution waiting. After 5 seconds, the result is coming. Are you able to follow this now? Program execution is calling like that. Are you able to get my point or not? So GC calls a del function and we got the at the end of it. If I run my first program, non-destructor program, is there any special advantage we are getting with this? Nothing. Only student can understand that practically. Internally, garbage collector is calling the destructor automatically at the end of the program execution. That is only the flow you can understand. Are you understanding? What is the use of garbage collector? Garbage collector running behind the Python program, whose role is to eliminate objects memory space by automatically calling the destructor function. So time dot sleep of what? 5. After 5 seconds sleep, and this is going to be calling. Are you able to understand? Now, next I want to go for computing the memory space. Students in the online, are you able to understand this discussion now? How many objects are created here? 3 objects. How many times GC is calling the destructor? 3 times. If I create 100 objects, how many times it is calling? 100 times it is eliminating, because each object is having its unique address is there. Now I want to go for same program with a memory space computation. I will go for it. Take care, students. Now I am going to introduce one small point. What is my point here? You see what I am taking. Program execution started. Now I am going to take destructor example 2.py. Now I am taking. Take care, students. Now I am going to take it. Total memory space, TOT memory space, TOT MEM space is equal to TOT memory space is equal to what? I want to get the memory space size of E1. First time you are getting in the class. There is a module called what? Sys. How to find the size of the object? Get the size of. Sys is the module. Get size of is a function present in which module? Of what I will say? E1. What it will give you? Memory space of what? E1 object. For your better understanding, I will write what? TOT memory space. I'm just printing it. I'm printing it. TOT memory space. Import what? Sys. So 2.py. Just run it. You will come to know the memory size. Coming to the point of, you execute destructor example 2.py. So you got it. 48 bytes of memory space, one object is taking. 5 seconds waiting, and then after that calling what? Garbage collector is calling destructor. Like that, I will write what here? Sys dot get memory space of what? E2 plus get memory space of what? E3. What is the 48? How much? 48. Total memory space of current program is equal to comma what? TOT MEM. What is that? Space. Now I am writing like that. You see, students, and see that total memory space of an object is what? 144. 44, 48, 48. So this you remove, students. Now my point is, once this is going to be like that, what are you supposed to do? You are going to do what? First time where it is going? Del. What is the first time calling here? When first time calling, how much memory space? What is the total memory space actually? 144, the initial state. Next, when first time destructor is calling 144 minus what? 48. How much it is left out? 96. When second time calling, what is the memory space removed again? 48. What is the memory space left out? When third one is calling, what is the memory space it has with the program? 0 memory space, because it is removed everything. So that I want to show you. How do you do, students? I say TOT memory space is equal to, come on, TOT memory space is equal to TOT memory space minus one object remove means that object memory space to be removed or not. TOT memory space minus, tell me, sys dot get, what is that? Size of, come on, self. Self is a good, because E1, E2, E3. Suppose if we write E1, what will happen? Brain panja. What is E1? When E1 was removed first time, second time when E2 come, E3 will come. Do you have E1? Which error will come? Name error will come. When E1 was removed first time, when second time it is coming for subtracting and deleting that memory, do you have E1 there? No. What will be there? Self will be there. If you don't understand self, you lost your self. Self, nothing is there. You have to push the vehicle, that's all. So TOT memory space minus sys dot get size of self. What is this is? What is TOT memory space? TOT memory space is called what? Global variable. And total memory space నాకు అర్థమైంది అక్కడ. అది కాదు పాయింట్ ఇప్పుడు. TOT memory space is called global variable. అది పాయింట్ ఇక్కడ. When I am going to modify my global variable in any of the function, I must write what? Global TOT memory space. This is totally you are out of order. A thought లేదు మీకు. You did not get the thought of that. I am doing the modification on that. What is that now? What is that now? What is it? Current memory space. Current memory space. Current memory space. Now I am writing dot format of what I am going to say. Dot format of what? TOT. What is this now? Memory space. TOT memory space I am writing. TOT memory space I am writing. I think you are following me. I think you are following me. Before that, what I do today is I will just go for what? You know, TOT memory space. I will write this statement in where? I will write this statement in where, you know, student. I will write this statement in this place. Where I will write it? After that, you will write this type of thing. I will write in this case. Current memory space and the total memory space. Total memory space of current program available. Still, total memory space of program still available. Total memory space of current program still I will write it. Are you able to get me? Now, try to understand this point and then carefully try to understand. Let me run this code. Let me run this code. Line number 16. What is that? Close this bracket. Take care. I'll save this code, run this program. Now see this now. What is happening now? It is giving total memory space with the program is 144. Program execution ended. Why this is written in the beginning of the program only written? When it is ended, what is calling? First object removed. What is the memory space? 96. What is the total memory space of the program still? 96. GC calls another which is removed the second object memory space. What is the current memory space? Still total memory space available in the program? 48. GC calls the third object also. Current memory space is what? 0. What is that now? Still the program is available. Are you able to follow? Now I am going to write it. Now I am going to write it. Time dot sleep off. Time dot sleep off. 5 seconds each time it is calling. You see, students, what is happening? Still sleep function is not taking care into consideration. What I am doing is, that part is, still even if we call sleep time, sleeping over there, it is not working there. I will just call it as what? Sys dot, sleep off. What are we doing there? 5 seconds or 2 seconds you say, and see the final result of the program. Are you able to get my point? What happens here? Line number sys dot, okay, time dot, sorry, time dot I need to say, time dot. Here also I will write it. Time dot sleep of 5 seconds. You try to understand, students. So here I am getting, even if you write time dot sleep of where? Inside of where? Destructor. Destructor, garbage collector will not sleep because garbage collector is not under our control. It is under the control of the PVM. Did you understand this accounting process? What did you understand basically this entire thing? One should not write this sleeping mechanism because garbage collector is under your control at all. So finally, I am going to say and try to run this finally. So this is my program execution. Total memory space is like that. And I'm going to get it next what? This is the memory space what we have it. Is it clear up? Right. Now, is it necessary to write destructor or not necessary to write destructor? Not necessary to write the destructor. Shall I move forward? Now, I'll go to the next part of it. Next, I'll go for it. Constructor called by whom? PVM. Destructor calls what? Called by garbage collector. So garbage collector is an upper layer or destructor is an upper layer? Garbage collector is an upper layer. Internally calling what? Destructor. So destructor eliminates the memory space. Constructor initializes the object. Now I will go to the next case. When the garbage collector is calling here at the end of the program, that is known as what? Automatic garbage collection. What is that? Automatic garbage collection. Automatic garbage collection. Now I want to do something like this. I got an object E1. Next program I am going to take up. Next program I am going to take up. Carefully try to follow. Here I am going to write it. Here I am going to write. Memory space and everything I don't want to take up now. You already know that. You already know this entire stuff. Now I will remove it. And the total memory space also you understood. Now I am going to take up. See the students. So total memory space computation already done. Program execution started. E1, E2, E3 program execution ended. This is what we are going to discuss. Destructor example 3.py. 3.py. Import time.sys. Constructor is there. Destructor is available. Now, my point of time is once an object is created, generally garbage collector is calling at the end of the program execution. Here it is calling, right? But my interest today is I want to make the GC2 call. I want to make the GC2 call destructor. I want to make the GC2 call the destructor forcefully before the program execution ended. Here two varieties I am going to say. One is the automatic garbage collection. One more is forceful garbage collection. What is meant by forceful garbage collection? Whenever the programmer want to call the destructor, that time I can make the GC2 call the destructor by with the simple statement. What is the simple statement? You carefully follow. Here I am going to write it. E1 object is created. I got the data displayed. Here my requirement is print of no longer interested to maintain object E1 memory space. E1 memory space. Why? Because I initialized my object. I got the result also. And I'm not interested to maintain the E1 memory space for a long time until the program execution is over. Morning 9 o'clock only my objective functionality over. Why should I maintain the memory space of E1 at the end of the 6 o'clock night, evening? 6 o'clock is a garbage collection, automatic collection. But E1 object purpose is over at what time? 9 o'clock only. So why should I maintain the unnecessary this object memory space with my program, right? So I should eliminate then and there to make my program as a lightweight component. What should I do? That time I should write E1 is equal to what? None. E1 is equal to none. When you make it as a none, making it as what? Nullifying the memory space. Making the memory space as what? Null. A null is a word in Java. In Python, we use what? None. So we are getting none importance today. Already we know none, right? None is a value of what? None type data type, which is used to make the object memory space to be destroyed by calling the garbage collector. The moment when I write E1 is equal to none, what is calling? Informing the garbage collector to eliminate the memory space of what? E1. So automatically garbage collector will come forcefully and calls what? Destructor. Did you understand? So I'm writing here time dot sleep. For your understanding purpose, I am saying this word will come and then this is immediately calling. Next I am writing what here? One more thing I am writing. No longer interested in what? Again I am going to create what? Again I am going to create what? E2. What object is creating? E2 object is creating. See this carefully. After the destructor is calling that E1 memory space, I'll take some time, some 3 seconds. I'll create an object E2. No longer interested to maintain what memory space? E2 memory space. Make E2 something like 5. Make E2 as what? None. E2 as what? None. You make it as E2 as none. Next, E3 object you created. E3 object you created. E2 object where I am creating? E2 object is already created. Now E3 object you create. Now that E3 object will be removed at what time? Program execution ended, because I am not calling forcefully. So here two mechanisms are there. One is called what? Forceful garbage collection. One more is automatic garbage collection. How many mechanisms are there to call the garbage collection? Two. One is automatic garbage collection, forceful garbage collection. What are the syntax for forceful garbage collection? Making the object of my current class program as a none. Making the current class program as none. Finally, I will write a time dot what? Sleep of 5 seconds. After the sleep of 5 seconds, which object is removed? E3. E3 object. Try to run my code. Very easy. Save this code. E3 run. Now see that now 3.py. See that no longer interested to maintain even memory space. After a few seconds calling GC. See, GC calls del for removing that. E2 object is created. No longer interested to maintain E2 memory space. Still it is calling the GC. Program execution ended. One more GC will call the next. Last GC is what? Automatic garbage collection. Before the program execution ended, how many objects are removed? What are the two objects removed before the program execution ended? Forceful garbage collection. And at the end of the program, we called that. What is that? Are you able to follow? So did you understand this meaning? Now, let us go for, if I want to make it to do everything in the beginning only, one can do. This is called E3 is an automatic garbage collection. E1 is called what? Makes GC to call it's a destructor. It's a destructor. Destructor forcefully. Right? Makes the GC to call its destructor forcefully. Here also I'm making it to call forcefully. Are you following me? And at the end of it, what? Makes the GC to call its destructor automatically. So I'm going to write it. Did you understand, students? Now, coming to the point of it, Abhay, please follow me, student. Don't excite by yourself. Abhay, so be Abhay. I will explain everything. Don't excite by yourself. Abhay, take care. Now coming to the another point. So you need to remember you are in which class. You are in my class. I'll tell you everything for you. Don't worry about it. One day, I told you already in the class, del operator I told you. What I told you, del operator? Del operator removes memory space, calls the garbage collector automatically, I told. Which time? List time I said this. Today I am using that. Here what I am doing? 4.py. Now I am writing E1 is equal to none. You can also write what? Del E1. Del E1. Del of E1 is wrong answer. Del of E1 is wrong answer. So, Abhay, you are also wrong answer. Del E1, that's all. Del of E1, if you write it, del of will become a function. Del is an operator, I said. So, that's what? Of knowledge is more dangerous. So, del of what? Del E2, that's all. E2. Now I will write what? No longer interested to maintain what object? no longer interested to maintain what object also. So I'm writing E3 object also no longer interested to maintain. Sleep of it, some 3 seconds. Del of what? E3. And last, nothing is there to call. Sleep of 5. Program execution is ended. After that, nothing is there. Nothing is there to call it. I'm just taking 3 seconds. Are you following? So how many ways are there to call the forceful garbage collection? 2 ways. One is making the object is equal to none. One more is making del. Del is called what? Operator. Right? Abhay, are you okay? Now I will execute. Now I will execute. Line number 20, what happens? Del E1. Del E1. E1 is an object. Del E1. So some small space is there. Very good. So Sandeep Singh, very good student. Sandeep Singh is very good. See, even I did not recognize. So Sandeep Singh, Prashant, Deepak, Abhay, some students are there. They are always observing spaces, all those things. Offline boys are also there, sitting like what? Meditation gurus. Right? So don't feel it. Even if you feel also, no problem. See, Sandeep is saying, I gave a small space. Even I did not remember. He's saying, sir, line number 20. That is called commitment. So PY, coming to the destructor 4, see that del operator I used today, del operator. Here, calling that. Because I said what? Del E2 object initialized. E2 object also removed by using what? Del operator. And no longer interested to E3 also. That also over. After the program execution, nothing is there to call. Why? Before only my programs over or not? This is comes under what? What kind of things? Del operator? None. It is comes under what type of discussion? What type of concept it is? Forceful garbage collection. Shall I go to the next level? Right. Abhay, Tushara. Are you getting ma Tushara? How many objects are created? 3 objects. How many times garbage collector is calling destructor? 3 times. Shall I go to next level? Yes. So coming to the point of it. So next example I am going to take up. See how beautiful example it is. So these are all called enlightening your skills about garbage collector. Go to the place. Now I am going to take up one more type of example I am going to take up. Look at students. This is my destructor example 5.py. 5.py. Take care. Program execution started. E1 is equal to what is this now? Employee. Now I am taking 100 comma rosum. I am taking this is one object. E2 is equal to E1. E2 is equal to E1. What is that line is called? Definitely you cannot say. Somebody saying good. Deep copy. Very good. Deep copy. Long ago, the copy techniques are there. Shallow copy, deep copy. Somewhere else we heard about it, right? Deep copy. That is called a deep copy. Deep copy. How many objects are created now? How many objects are created? One object only created. How many objects are pointing to that memory space? 2 objects. E3 is equal to what? E2. What copy this is? Deep copy still. How many objects are created? 1 object. How many are pointing to the same memory space? 3 objects. Print chudandi. E1 ID of E1, comma ID of E2, comma ID of E3. ID of E3. Just I wrote it. Just I wrote it. And don't worry about this GC today. Don't worry about this GC today. I'm not writing that. So you just follow me carefully. Destructor example 5.py. 5.py. Out of that, you execute destructor 5.py. What ID? Same ID or different ID? Same ID. Same ID. Okay. Now coming to the point back. Now I am coming to the point back. Here my question is, 3 objects are created pointing to the same memory space. Garbage collector is there. Now I am asking a question. Time dot sleep off. time dot sleep off, some 5 seconds I said. Tell me, at the end of the program execution, how many times garbage collector is calling destructor? Quickly. 1 time or 2 times or 3 times? Come on, open up. 1 time. Why 1 time? Because only one ID will be there. 1 time or 3 times? That means this is a question. When multiple objects are pointing to the same memory address, when you program execution is ended, is 3 times garbage collector is calling destructor or 1 time? Test it. Go to the program now. So who is that 3 times? So Kavi Anjali 3 times. How 3 times? First, see that why I shown you this address, for making you to understand that one memory space only created, 3 things are pointing to it. How many memory space will be removed? 1 time only memory space is removed. Please point to that. Coming to the point of it, what is happening? Program execution is ended. So see that 1 time only it is calling. Earlier it was called how many times? 3 times. Now it is calling how many times? Why 1 time? Even though we created a more number of objects, all of them are pointing to what? Same memory space. That's why GC calling what? This is known as automatic garbage collection or not? Let me go to the next. Let me go to the next stage. See students, I am going to introduce this example. What is this now? 6.py. What I am doing? These things are calling. What I am doing today? No longer interested to maintain that memory space. Which memory space? No longer interested to maintain? E1 memory space. No longer interested to maintain E1 object memory space. Time dot sleep off del of E1. Either a del you can use or E1 is equal to none, you can write it. Will the garbage collector will call it forcefully or not? I want the answer. Here del of E1 you are saying. Will it be called or not? Come on, quickly. Yes or no? Answer. Don't keep it suspecting. Suspecting means it's a dangerous. You decide. Yes or no, you decide. Calling or not calling? Calling? See. Calling. Wrong answer. Now tells me wrong answer is so students will say wrong answer first. Now, and don't feel it. I'm saying openly because I speak everything open. So student will change means change. Not changing means not changing. 80% will change. 20% they'll still like that only. Here what is happening? 10 row sum and this is some data is present. Okay, row sum. And this is E1 is pointing, E2 is pointing, E3 is pointing to what? Same memory space or not? 4664. This is a date address, right or not? Which object you are killing? E1. When E1 is killing, who is pointing still? E2 and E3 pointing to the same memory space or not? Will garbage collector will come and touch the memory space? Huh? No, somebody is pointing. Simple students. You are coming from international airport. You found a big bag of gold which is containing 10 kgs. 3 friends are there. 10 kgs of gold. Friend 1 and a friend 2 and a friend 3. It's a bag. 3 people have seen it and 3 friends are there. They want to share it after coming out of it. They came out of it. Whose address of the bag is 1, 2, 3. What happens? Your friend 1 said, friends F2 and F3, I am going to just outside for 5 minutes. I will come back. I'm just going outside and I will come back. I just is going to take a cup of tea outside. And please be there at the bag only. Will any thief will come and collect away this gold bag? Why? 2 people are already pointing. And this person went off. F2 and F3 still pointing. They won't come. Now F2 also told to F3, I will also take one small coffee I will take. You wait. Still point to the bag only. F2 also went just 2 minutes outside. Will the thief will come and collect away? Now, why? Still F3 will point. And F3 felt that, okay, they went outside, na, just far away. I'll also go just for what? Taking water nearby. He also went outside. And thief found that nobody is pointing to that. And it is removed by what? Garbage collector. If no object pointing to that unique memory ID, that will be automatically removed by what? Garbage collector. And don't tell that gold example in interviews. So you are very danger. Student is always, even I am a student, I am a danger. Because student will say always wrong things only. And without knowledge. With the knowledge, if you don't read the notes also, wrong answers will come. Openly telling to you. Correct or not? Tell me. E1 is an object which I am doing what? Del. Is the garbage collector will come and touch this memory space? No. What? Why? Still it is pointed by what? 2. I will make U2 also none. Will the garbage collector will come and collect away? Still who is pointing? E3. After saying E3 delete, that time only it is coming to the point. Getting my point? See now. Here you understand now. No longer interested to maintain object E1 memory space, sleep off, time off like that. Del E1, not calling. Again I will call it. Which one? Which one I am doing, students? No longer interested to maintain what? E2. E2 is equal to what I am doing? None. None. Still not maintaining, not collected. Why? E3 still pointing. So here GC will not collect. GC will not collect. GC will not collect. GC will not call. Will not call. What? Underscore del. Underscore del function will not call. Because E2 and E3 points to what? Same memory. Same memory. Same memory it is pointing. Same thing. Here also, I will write it here. I'm writing. GC will not call this one because E3 points to what? Same memory. Now I am writing at the end of the program execution, I am calling sleep of 5. I am saying this is called what? Something like let it be 3. I am taking 3. And then last, at the end of the program execution, what is removed? E3 memory space is removed. That is called what collection? Automatic collection. Just observe it. Last and final. I am going to say, see this now. Execute it. PY. See that. No longer interested. Not calling. Why? E2 still E3. E2 also becoming null. Not calling. Ending is done. Last it is calling. Even though I removed 2 objects, those 2 objects memory space is not removed because still it is calling. Last it is calling or not? What is it called? Even though multiple objects are participating in deep copy, only one object is existing. That only one object is removed by the destructor last. Getting my point? Yes. Tushara, Abhay, what you asked, more than that you are getting it. Tushara. So if I create a multiple object, as Tushara said in the beginning, 3 objects created 3 times destructor is calling. That is a wrong sentence. 3 objects with a different unique IDs are there. 3 different IDs are there. That time 3 destructors will call. But here 3 objects are created. According to that sentence, if we think it is a wrong or not. Now 3 objects are created. Participating in which copy? Deep copy. How many times it is calling? 1 time only. So subject is important. Are you following me? Let me go to the next. So coming to the point of it, beginning to ending of the class, if you listen, you will become a master. In the middle, if you excite now, problems will come. So coming to the point back, here I am writing, no longer interested to maintain what? E3. Now I am telling what? E3 is equal to what? None I said. None I said. So GC will call what? I am writing last. Will call del because no objects point to. Because no objects points to what? Same memory. Are you following now? Done. Shall I execute? At the end of the program, will it be any destructor calling here? No. Why it is calling in the last? So coming to the point back, 7.py, say this 7.py. Now I'm saying that execute it, py. This is done. See that no longer E1 is maintaining, E2 maintaining, E3, that time GC is calling. It is calling now. It is calling now. Now program execution ended, nothing is happening. Got it? Everything is live. Is my garbage collector definition remembered or not? Is it eliminating the memory space or not? If anybody asks you, you created 3 objects, compute the memory space, show the memory space, how it is reducing it. Understand, students? Right. Now I'm going to say here, if you want, this is a way to call your object's memory space. Getting up? Fine. Go to, this is called a destructor concept. Normally, see from the beginning of the program, non-destructor example, non-destructor example, destructor example, writing del. And this is a destructor example with 3 objects, total memory space computation. Next is called what? Destructor object in the middle only forcefully calling. And next after that, what is happening? Before only calling forceful garbage collection with a del operator, with a none. Next is called what? Deep copy. Deep copy in the before, deep copy at the end calling. Deep copy all the objects memory space collecting once only before program execution ended. Understood? Now, I want to tell you one module is there. Of course, there is no meaning for the module at present. Tell me, is it necessary to write destructor in our present program in real time? No. But internally, what is calling? Every garbage collector is calling destructor. Which destructor? It has its own destructor that will be called automatically. Shall I move forward? Okay. Now, first of all, you need to ask one more thing. This is about destructor example, student. Now I'm going to introduce. Okay. Destructor is, garbage collector is calling destructor. We have seen it. Now you need to tell, sir, you said behind of every program, garbage collector is running. You show me garbage collector running. Whether it is running or not, how can I know? With this, almost you understand. One more point I want to say. Just look at students. Print, program execution started. Program execution, normal program execution started. Program execution started. Next I'm writing program execution ended. Program execution ended. This is program execution ended. Now I'm going to say GC example1.py. I'm talking about it. Program execution started. Program execution ended. What I'm doing there? There is one module is there, student. What is that module name? Import GC. Actually, GC module doesn't have any importance in 3.x versions. In 2.x, there was some meaning. In 2.3.x, there is no meaning. Why? We never bother about garbage collection calling from the programmer side. It is automatically cleaning the process at the end of the program execution is completed. Okay. Now I am going to say some A is equal to 100, some B is equal to 100, C is equal to A plus B. After that, A is equal to B is something like this. I am writing one simple statement, student. Is GC running? Is GC running? I want to check in the middle. Is GC running? Or beginning of the program or ending of the program or whatever it is. There is a function called what? Come on. Is, now I am saying, is GC running? There is one function called what? Enabled. Enabled. What is this now? Enable. So, is enable. Is enable. Enabled something like is a function. Is enabled. Ante, is garbage collection is enabled by default. Is garbage collector is enabled by default? Not getting. English problem. When the human being came to the natural earth, what is enabled automatically? Breathing will enable, right or not? Correct or not? When human being creation starts, what is created first? Breathing will start. That is called live, right or not? Is enabled returns true when the garbage collector is internally running. Understand? Right. Is enabled is one of the function in which module? It returns true when the garbage collector is running internally. You run this code. Now I am writing here, print what? Value of A. Already you know this, just I am writing for the sake of that. Next value of B I am writing. Value of B I am writing. Next I am writing print. Sum is equal to comma C I am writing. Just a minute. E is enabled. Execute it. Go to the place. GC. Execute it. Line number 10. Line number 10. Okay, students. PY. See the answer now. Is GC is enabled? True. That means GC running or not running? So people will ask, how can you make me to understand GC is running? You need to show this. Running or not running? Running. Now, in the middle of that, after printing A, I am writing GC dot disable. GC dot disable. GC dot disable means is disabling means stopping. Right or not? Disable means what? Stopping. Now see, is GC enabled? Is GC running after disable? After what function? Disable function. GC dot is enabled. What is the answer? Come on. False. See the answer now. See the answer now. Is GC running after disable? False. So do you feel that? Is it running or not running? Come on. Not running. Okay. Now you see. GC dot what? Enable. What is that now? Enable. Again I am going to start. What is happening? Again I am going to write it. Again I am going to write it. What is this? Is GC running after enable? Enable off. Enable off. What is enabled? True or false? True. See the answers now. See the answers now. Is GC running beginning? True. I disabled it. It is called what? Is GC running after enable? True. So that means you are controlling the flow of what? Garbage collection. Are you following me? So do you feel that? Are you able to stop and start the garbage collection? Enable, disable, enable. Are you controlling the flow of garbage collector or not? Now, actually, coming to the point of it, now I will go to the program. You take any one of the program, beginning program, you take it. This is a one. You take this program. I will copy. I'll copy. See now, GC example 2, I'm writing. Because these are all very, very important students. GC example, what is that? 2.py. Here what is happening? Here what is happening? Here I am going to say, is GC running? Is GC running is equal to, what is this now? GC dot is. Come on, mom. Enabled is enabled. What is the one I need to say? GC. Comma, I will write a comma. Comma, I will write it. Now tell me, is it enabled? So see that carefully. At the end of the program, how many times destructor is calling? Come on, program execution over. What is happening? Calling destructor how many times? So see this carefully. Run this program now. Example, is GC is running? Yes. 3 times destructor is calling. 3 times destructor is calling or not? Now my point is, after this enabling, I am going to call it GC dot disable. GC dot what? Disable. I said what? Is GC running? Is GC running after disable? Come on. After disable. What is it? False. When it is false, now tell me. Now I am going to take it 20 seconds. And after showing this false, 20 seconds I will wait. Every student has to observe very carefully. 20 seconds I will wait. 20 seconds means you tell me, is the destructor called or not? I'm disabling now. Disabling means what? Come on, false. Will it call or not? Come on. Everybody. No. Yes, sir. Disable చేశాను కదమ్మా. When you are disabling in your cell phone some option, will it be enabled? So will it be called or not? Come on. You are looking at me. Sir will say definitely no. So your answer is wrong. Because you already understand my mindset. Subject you are not understanding, but you understand my psychology. So it is you are understanding. Once it is disabled, it is becoming false. Every student will think that garbage collector will not call. Students, garbage collector as on today is not under the control of the programmer. When you disable it at the end of the program, automatically your PVM will make, your OS will make the GC to enable it automatically. The moment when you enable, at the end of the program, it will see. If you don't enable it, automatically it will be enabled. Did you understand? So see that now. I will wait for 10 seconds. I'll wait for 10. Even though I disabled it, it is not going to call this destructor. What students will think. But I'm telling to you, this is a gunshot question. What the question is coming? If I disable my garbage collector programmatically by writing gc.disable, is the garbage collector calling the destructor or not to eliminate the memory space? What is your answer? Answer is yes. GC is not under the control of the programmer. It is automatically enabled by the PVM and then underlying OS. See now, execute it on all the students in the online. So you are made it false. Still you made it false. It will call. It is not under your control. Only for the sake of the message it is coming. See, calling or not? Called or not? Has called it. So it indicates what now? Is the garbage collector is under your control? No, it is under the control of PVM as well as what? Underlying OS. Students in the online, is this point is clear? What is the GC module? Is there any real use of GC module in 3.x? No. Bag phone, bag lo bettandi, phone lo bag lo bettandi. Class lo uchina phone lo taadukuntunnaru. So now I'm going to call it as what? Disable no use, enable no use, all these things no use. So all these things finally what is happening? GC no use and a garbage collector destructor, you need not to touch it. Automatically they are going to use it. Are you following me? So coming to the point of it, all the students in the online, I hope it is clear. Is it understandable, students? Now I'll go to this whoops. Destructor is there. Destructor concept is available somewhere else. I'll get the notes here. So 7 AM, I'll get the oops. Destructor concept is there. There I will place the notes. And see the notes here, I'll open it. So here you see students, I'll see. Look at all of you, read carefully, one by one, you can understand. Start. We know that garbage collector is one of the inbuilt program in Python, which is running behind of every Python program and whose role is to collect unused memory space and improves the performance of Python-based applications. Performance of what? Python-based applications. Next, every garbage collector is internally calling its own destructor function. The destructor function name in Python is def __del of self. See students, self after that it won't take any parameters. Because the destructor will not delete the parameters of the object. Destructor will remove the total object only. Understand that? So by default, destructor always called by garbage collector when the program execution completed for deallocating the memory space of objects which are used in that program. Whereas constructor called by PVM implicitly when object is created for initializing the object. Constructor will initialize the object Destructor will remove the memory space. So when the program execution completed, GC calls its own destructor to deallocate the memory space of objects present in the program, and it is called automatic garbage collection. Hence, we have three programming conditions for calling GC to make the garbage collector to call destructor. A, by default or automatically GC call destructor when program execution completed. Make the program reference as none by calling forceful garbage collection. Syntax object name is equal to none. Delete the object by using del operator by calling forceful garbage collection. Del object name. Del of you don't write. Del of is called what? Function name. Should not write it. Syntax def underscore underscore del underscore underscore of self. It is called what? Close some statements you are writing. And we never write in real time. And strictly every real-time programmer will say in the industry, don't write any destructor in your program. Why? GC already contains its own destructor. Next, no need to write a destructor in a class of Python because GC contains its own destructor. Getting that importance? Come to which one? So garbage collector contains a predefined module called GC. GC contains the following functions: is enabled, enable, disable. GC is not under control of programmer because it always maintained and managed by OS and PVM. See, Python programmer need not to write a destructor method or function and no need to deal with the garbage collection process using GC module because the PVM and OS takes care about automatic garbage collection process. But this knowledge is required. Interview will ask compulsory now. This is about what concept? Garbage collector concept and then destructor. Are you okay, students? Now come to that. Destructor in OOPS with garbage collector. Importance and purpose of destructor. Syntax for defining destructor. Internal flow of destructor. Relation between destructor and garbage collector. GC module and programming example. Clear up? Now I will show you one object concept. Daily we are following object only, E1, E2, etc. What is the use of objects in Python? Class is over. Class concept is over. What is the definition of class now? What is the definition of class now? If I am asking, a class is a collection of data members, methods, constructor, destructor. This is a perfect definition of class. But our source already said to you, class is a collection of objects. Blunder, na? Blunder or not? What is a class? Class is a collection of these many. Using class, we will create what? Objects. To store what? Data. So what is the use of object? To store the data. To create an object, what is required? Class is required. Class first, object first. Class. Class is a collection of what? Data members, methods, constructor, destructor. What is the definition of object? Instance of a class is called object. What do you mean by instance? Allocating the memory space for data members, methods, constructors of a class. Are you getting my point? So without object, we cannot do any data processing. Did you understand that? Today I want to show you a simple point of what? Object I want to show you. I will bring the object concept for you. Object concept I will bring it. So I will go to the place called what, 7 AM. I will take here what? Object I will keep it. Look at students. I'll go for one small documentation. Seema, all of you, try to read. Come on. When we define a class, memory space is not created for data members and methods. But whose memory space is created when we create an object with respect to class name? Already we did an object. Today I'm showing the documentation. The purpose of creating an object is that to store the data. To do any data processing, it is mandatory to create an object. To create an object, there must exist a class definition. Otherwise, we get what? Name error. Without a class name, if we write an object, creation of an object, will you get name error or not? Yes. Definition of an object. Read out. Instance of a class is called object. What is instance? Instance is nothing but allocating sufficient memory space for the object and data members of methods of the class. Syntax for creating an object. Variable name is equal to class name of, or variable name is equal to class name of value 1, value 2, value n. You tell me if you are so good student, what is this line is called? Creating an object with which constructor? Default constructor. Creating an object with which constructor? Parameterized constructor. That's why I'm teaching after the constructors, destructor concept. Tell me now, create an object student. SO is equal to what? Student of. Create an object of student. EO is equal to employee of 10 rows sum. Default constructor calling, and then what? Parameterized constructor is calling. Differences between classes and objects. See how simple. A class is a collection of data, members, and methods. Immediately you see object. What is that? Instance of a class is called object. When we define a class, memory space is not created for data, members, and methods, and it can be treated as specification or model for real-time application. When we create an object, we get the memory space for data, members, and methods. Right? This chart window, I will get it down. Next is called a definition of a particular class exists how many times? One time. Employee class will exist one. E1, E2, E3 I can create or not. With respect to one class definition, we can create multiple objects. When we develop any Python program with OOPS principles, class definition must be loaded first in main memory. How many times? Only once. After, we can create an object after loading the class definition. Otherwise, we get what? Name error. This is the differences between classes and objects. Clear up? See, last Thursday onwards, we are discussing classes and objects. You search in these things in any internet, you will not find. Search it. I think you already searched it. You search it. Still anybody did not search for it. First of all, you did not read the notes. I know that. Correct? Huh? Reading notes? Tell me, who is reading the notes daily? In this class, who is reading the notes? You raise the hands. I want to see. Okay, only one student. Only one student is raising. One girl is raising. Boys, who is reading the notes daily? Come on. Are you first of all downloading the notes? Huh? Downloading? Who is downloading daily? Raise the hands. Okay, good. Who is not downloading? Not downloading. No mogamatams here. No internal marks. I want to see your face, that's all. Who is not downloading? Maybe you will not raise the hand because that is the laziest job. Not downloading means the laziest job. You are thinking, breath is there in the air, na, total universal, 500 years are there. Na, that's why you are not taking the breath. Download as early as possible. So, daily downloading and reading. Good. Who are all doing my principles of class, which I said, they are very good students. In the day one, what I said, to you, in the day one, 7 a.m. So something like maybe I said to you, maybe I said in the day one, I don't know whether it is saved or not in your class. Already said to you something in the class. So day one, so some small thing I said. History somewhere else. History, beginning class, first day of the class, something I said. Reading the notes, practicing the notes, punctuality attending classes to become a perfection, I said. You also remember now? So try to do that. So anyhow, I'll stop. Tomorrow I will start with what? Abstraction and encapsulation, first 1 hour. Because that is very easy. And next I'll introduce inheritance concept, I will introduce. We should not miss the class tomorrow. Very, very important students. Don't miss the classes. Thank you. All the best. Online students, you can hold on. I'll speak to you if you have any doubts. Students in online? Tushara,
Hello, sir. Good morning, sir.
morning, ma.
Yeah, regarding this destructor only, Python is like functional oriented and also object oriented programming, right? So,
Yes,
so
ma.
when we don't create any class and we have assigned some variable a equal to 10, so with respect to that also destructor will be called, sir.
Yes, ma. What is A, ma? By the time you have to understand what is A?
Class of int.
Class of int. What is A then?
Object.
Object. So
Yes.
when that object is created, which class related destructor will call?
Int class.
Int class is already containing destructor, which is automatically called by the garbage collector.
Okay, sir. And one more thing with respect to static data members.
Static data members will not be there in Python. Class level data members.
Yeah. The class level data members. But for class, we do not have any memory space. Once the object is created, we will have the memory. But how the class level data members will have the memory, sir?
What, ma? How the?
Memory. How the memory is allocated for class level data members, sir?
Same as Java, what I said here also. I already told you that in the class. Course name is there, which is created what? One time memory space is created.
Yes.
So I told